Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today, we are going to discuss about a dropout in neural networks and deep learning. A dropout is a regularization technique used in the neural network and deep learning model to prevent overfitting and improves the generalization performance. It works by randomly dropping a set to zero or a portions of a neuron during each forward pass of training. The main purpose of this dropout, where we have a regularizations, preventing overfitting. A dropout reduces a noise to the network during a training by randomly deactivating the neurons. This prevents the neurons from co-adapting too much of a specific feature's presence in the trained data, thus improving the model's ability to generalize unseen data. Enables a learning, appropriate enable methods. Each training iterations with the dropout active can be seen as a training in a different neural networks due to random dropout patterns. By averaging the prediction of this enabling the model during the interference, dropout can provide a model averaging that can improve the performance. How this dropout will works? The training phases, testing phases, where the basic implementations how the dropout works. As a training phase, during the training, each neurons or the units in a network is retained with a probability and dropped out set of zeros with the probability. Testing phase, during the interference or the testing, dropout is typically turned off and a full networks with all neurons is active is based for making a prediction. However, some implementation using a scaled down versions of the network to appropriate that enables an effective observed during training. The effective of this network structure is have a sparsity, robustness. The dropout induces sparsity in the network by randomly setting some connections to zero. This prevents a neuron from relying too heavily on a specific input features or co-adapting to each other, thereby reducing the risk of overfitting. The robustness is all about dropout encourages the networks to learn more robust features and representations as a neuron cannot rely on the presence of a particular other neurons. The practical considerations or the effective or the benefits of this dropout have a placement of dropouts typically in the hidden layer. The dropout is often applied to the hidden layers of the network rather than the input or the input layer. This helps in regularization the learned feature and the representation rather than adapting the input and output map directly. A dropout rate hyperparameters. This dropout rate is a hyperparameter that leads to the tuned based on a specific data sets and the architecture. Commonly used ranges from 0.2 to 0.5 by, but potentially values depends on the complexity of task and the size of the network. As I states about the implementations and considerations in neural network, the training dynamics, the lower convergence, dropping out may result in the slower convergency during the training because the network is effectively learning with a reduced capacity in each iterations, increased computational cost. During the training, the dropout requires more computations due to the stochastic natures of neurons and activations. The benefits of the dropout was where improved generalizations by preventing overfitting. Dropout enables a network to generalize better to unseen the data, leading to improved performance on a test or a validation datasets. Simple implementation is all about a dropout is easy to implement and can be applied to various type of neural network architecture, including a convolutional neural network and recurrent neural network and the transformers. Compatibility with other technique. Dropouts can used with the conjunctions with other regularization techniques such weight decays, batch or normalizations, and data augmentations and further enhancements. The validations in dropout is a powerful regularization technique in deep learning that addresses the challenges of overfitting by introducing a noise into a network during a training. By randomly dropping a neurons and their connections, dropouts Dropouts encourages a network to learn about robust and generalized representation, leading to the improved performance on unseen data. The future implementations in all these purposes will further helps in meta learning. Hence, I conclude this when applied effectively and tuned appropriately, dropout can significantly enhance the performance and the stability of a neural network model across the various tasks and domain. I hope you are clear with this concept. Thank you.